Welcome back everyone to the Hello World Guide. This is another episode of the Raycaster series, and in this video we are going to improve our game a little bit by implementing some enemy behavior for our entities in the game. So for example, the monster should be able to react to being hit, and we'll begin this by doing some refactoring and also adding functionalities for dynamically removing things from the world, and later we'll also add adding things to the world, and we'll also need to figure out a way to kind of register different kinds of events on things. So currently we had thinkers, and those only had an update function. We'll need to also add functions for different events that may occur, and of course those will be optionally implemented, but we can still have those. So first of all, I'm going to begin by opening up state.h. Now this is a new file that I've created, and this is actually going to contain some important state variables. And the reason we create this is that we can just pass this state around instead of having to pass around the variables separately. That would kind of make our function declarations quite long, and this can kind of conveniently hold all of the data that's related to our game in one place. So this game state is just a struct which contains references to the game and the map along with a delta time float. And now if I open up thing.h, what you should be able to see is that now we include our state.h up here. Actually, let me just move this down here, and in our thinker we have got a function update, which of course now takes a state instead of taking the game, map and delta time separately. It didn't take the game before, but we will now take the game so that we can use the game to do different things like remove the entity from the scene or something. So we have that, and we have also got a new function here, also pure virtual, and this is the on damage function. So whenever an entity thing is damaged, we will call this function, and this will kind of be an event. And what you can see is that we have got this function thinker class here that inherits from thinker. Of course, that's the one that we are mainly using. And now this consists of arguments that can also take an update function along with a damage function, and it stores both of these here, update function and damage function. And what we do is that we initialize these in the constructors, and when we are updating, we check if our update function is valid, and if it is, then we update it, and if our damage function is valid in the on damage, we update that as well. And you can see that in our class thing here, we have got some different things to add the concept of damage and health. So first of all, we have got this float here called health, which by default is 0. We take that in the constructor, and we initialize two variables from it. One is the actual health of the thing, and one is the maximum health of the thing that the thing was created with. And this health actually represents the current health of the thing. So yeah, apart from that, you can see we have got our another function here called damage, which takes float damage along with a game stage, and this function will actually apply damage to an entity, decrease the health, and call any callback functions. And we've also got some functions for getting different stuff, like we've got a function for getting health, and we have also got a function for getting the block map coordinates of these things. Now you might be wondering, why would we need the block map coordinates out of the thing? We are currently only using them when moving the thing. Well, we are going to understand that in a second when we look at how we are going to remove the entities, because when we remove the entity in game, we also want to remove it from the block map. So that's why we have to have this public function that allows us to get those block map coordinates. Alright, so now in the thing definition, we have got two new things here. One is a string called thinker, and this will actually represent the name of the thinker, and all of our thinkers are stored as an unordered map of strings with shared pointers. So using a hash map, it allows us to specify the thinkers by name. And then we have got another float here called health for each thing. Now in thing.cpp, basically what we do is that you can see that here we just do some map collision and stuff, all of the stuff that we had earlier. Now in here you can see that what we do is when we are checking our, actually not here, so in here after our check map collision function, we have got a damage function, and this of course subtracts the damage from the health and sets that, but it clamps it so that it doesn't go below 0. We don't want the damage to be the health to be negative. And then if our thinker is valid, then we do thinker on damage, and we give it this, like the pointer of course, and then we give it the game state as well. So this is the callback function that is called whenever an entity or a thing is damaged. And here we have got our unordered map of thinkers. Here we've got this first thinker, that is a monster, and we just make sure to create a function thinker. For the first one we pass an empty function, like an invalid function basically, because we don't actually want to use it. And for the second one we have got a basically a lambda, and what this does is it checks if the thing's health is less than or equal to 0. If it is, then we use state.game.destroy to destroy the current thing, and this destroy function is implemented in the game. We'll get into that in a second. And when we are creating our thing definitions for the monster, you can see we specify the thinker as a monster and we specify the health as 50. So now if I open up game.h, what you can see here is that we have got a new function here called destroy, and we have got a array of iterator of our things, and I just use decl type because this is a long thing to type out. That's a nice feature. So we basically got a vector of iterators that we are supposed to delete when this is over. And the reason that we store the things that we are supposed to delete in a vector is because we should not obviously modify a vector, add or delete elements while we are iterating over it. We are iterating over it when we are updating, so we're going to store all of that stuff in the to delete vector, and in the very end of our update, or the very start of the next update actually, we are going to remove all of the things from this vector and we're going to clear it. So in game.cpp you can see at the start of each update function, what we do now is that we go over each of the iterator in the delete, and what we do is we get the block map coordinates of the thing represented by that iterator. We loop over the x and y of each of the block map coordinates, and then we remove that from the block map. And of course we do this to ensure that there are no invalid references to things that don't exist in the map. And then we erase our things from that position, and in the end we clear our toDelete vector. And after this, when we are updating, we actually don't update with the stuff directly. Instead we create a game state with the appropriate variables here, and then we just use that for doing everything. And now if I go here, you can see that when we are calling the destroy function, whenever we call the destroy function, it loops over the things, goes over all of the things iterators, and if if the iterator's value of the pointer is equal to the thing pointer that we were given as input, we push that back onto our delete vector, and then we break out of the loop. So yeah, that's pretty much it. And if I go ahead and run make right now, by the way, one thing that I nearly forgot is that in the player.h, now of course player also takes a game state, and what we do in player.cpp is, instead of printing whether we hit something or not, if we hit a thing, we just damage that thing with 10 damage. So if I go ahead and run make, what you should be able to see is that let me run this, is that we can now shoot the monster, and then the monster will disappear. So I can shoot the monster 5 times, and as you can see, the monster disappears, and the block map is also operated correctly, so I cannot I'm not colliding with anything, so it's working correctly. So yeah guys, this is gonna be pretty much it for this video. I'll see you in the next one, in which we are gonna do some more interesting stuff by figuring out some more interesting way, because currently the monster just disappeared. We need to have a better functionality for that. So stay tuned for that. Make sure to like and subscribe and share this video with other people as well, and I'll see you in the next one, and bye.